here we are given a group G on which we are given two relations R1 and R2, and now these two relations are defined as A and B are related by this relation R1 if and only if there exists some element G in the given group capital G such that the element A can be expressed as G inverse BG, and the second relation R2 between A and B is defined as A is the inverse of B or B is the inverse of A, and these two relations are defined for all the points or elements A and B in G. So now we need to find out which of these two relations or if both of the relations if possible is or are the equivalence relations. So first we look for the relation R1. We can see relation R1 is defined as in this manner, A equals G inverse BG, but from group theory we also know that this relation R1, when it is defined in this way, is the conjugate relation of two elements A and B in a group G. So we can also write it as A and B are related by this relation R1 if and only if A and B are conjugate elements in G. But in group theory, for every group the relation of conjugacy is well known to be an equivalence relation. Therefore we directly can say that the relation R1 is an equivalence relation. Now we look for relation R2, which says that A and B are related by this relation R2 if and only if A is the inverse of B or B is the inverse of A, we can also say. But we can easily show by giving a counter example that relation R2 is not an equivalence relation on the group G. So if we take the group G to be the ring of integers which is equipped with the addition operation. Now we know that in this group Z of integers with addition operation, the identity element is the 0, and also we know that any integer we take n in G, the inverse of n is always given by minus n, remember, with respect to addition operation, and therefore we can write n is R1 related to R2 related to n, that is n and m are related by this relation R2 if and only if n is equal to m inverse if and only if n is equal to minus m. But now if we write, we look for the transitivity property, then we can write to say if A, B and C be any integers, then if A and B are related by the relation R2, this is true when we can write A equals minus B, and B and C are related by the same relation R2, then we can write B equals minus C. But now if this relation R2 is transitive, then we will have A2, A and C are related by R2. If we assume this to be true, then we must have A equals minus C, but from 1 and 2 we see that C, which is from 1 and 2, therefore this relation R2 is not transitive, and hence option number 2 is true.